Hello friends, welcome to engineering tutorial. So today we are going to again resume our discussion on computer networking and data communication. So far in the previous videos, it's a while since I have posted any video on this subject. So we are going to pick up our discussion from the point where we left it. So in the videos that I have posted in data communications and computer networking, and you can check out the playlist, we have covered all the introductory concepts. We discussed about the various network models. We discussed the open system interconnection model, the OSI model. We discussed about the various layers. In short, we have not gone into details of all that. So we are going to take the discussion forward, and in this video we are going to discuss about the TCP-IP model. So we discussed the OSI model, OSI network model. So today we are going to discuss about another important network model, which is the TCP-IP model. So I would like you to please check out the previous videos. I have posted around, I think, 10 to 15 videos, I think, yes. So please check out those videos first and then watch this video. Okay. So the TCP-IP model, so it is also a network model similar to OSI model. So before that, let us just have a quick look in order to refresh our concepts about the basics of network models. So the important parts of data communication through a network model, it involves devices or nodes, whichever device we are using, be it a smartphone, be it a computer, or any other electronic gadget which is connected to the internet. Then is the network. Now basically a network is a group of multiple of such devices or nodes. Okay, a group, many devices or nodes which are linked with each other and are capable of sharing data with each other forms a network. Now we discussed various types of networks such as local area network, wide area area network, metropolitan area network. So I have discussed it in the previous videos. So please check out those videos first. Then applications. Now the application is a particular program running on the device or a node. Whichever program, whichever app you have installed in your phone or in your computer and you are using that is the application. So these three things are important for the exchange of data between the various devices. So various concepts are associated with it. So an important part of this communication process is the network architecture. Okay, what type of architecture, what type of protocols, rules and regulations are followed for that data exchange between the various devices, that is defined by the network architecture model. So two of such popular models are OSI model and TCP-IP model, which we are going to discuss today. OSI model we have already discussed, the open system interconnection model. Then we have is the TCP-IP model, which is transmission control protocol internetworking protocol model. So we will come to that, what exactly that means. So the TCP-IP model, similar to the OSI model, it follows a layered architecture. Okay, layered network architecture. So it basically consists of 5 layers. Now in various other places you will find it consists of 4 layers, where the bottommost 2 layers that is the physical layer and data link layer, they are combinedly called as host to network layer. So whichever way it is given, whether we call it a 5-layered system or a 4-layered system, it means the same thing. So basically we will call it a 5-layered network model consisting of, starting from the bottom, the physical layer, the data link layer, the internet layer, the transport layer and the application layer. So these layers are present in the TCP-IP model. Now if we compare it with the OSI model, OSI model is a 7-layered system, okay, consisting of physical, data link, network, transport, session, presentation and application layer. So if we compare these two models, you will find that the network layer, it is called as the internet layer in TCP/IP, and session and presentation layer, they are absent in the TCP/IP model. Okay, so this is the basic difference between TCP/IP model and the OSI model. Now the host to network layer, okay, this physical and data link layer combined together, the host to network layer, it is equivalent to the physical and data link layers in OSI. So as I said, you can combinedly, you can combine these two layers and call it as host to network layer, or you can represent them as two separate layers. So it all depends what approach you are using, it means the same thing. So this physical and data link combined together, it forms the host to network layer. Now this internet layer in TCP/IP model, it is equivalent to the network layer in OSI model. Okay, the third, the internet layer here in TCP/IP is same as the network layer in OSI model. Okay, now both these models TCP/IP and OSI, they have the transport layer. Okay, see here it has transport layer, here also it has transport layer in the 4th level, at the level 4, here also at level 4 there is transport layer. It is the same in both the models. Next, session and presentation layer, it is absent in the TCP/IP model. So the application layer in TCP/IP model, it performs the task of the session, presentation and application layers in OSI model combined together. So the application layer in TCP/IP is equivalent to session, presentation and application layers combined together. So these are just the various ways of representing a system, okay, a network architecture, whether you follow the OSI model or TCP/IP model. When you follow any book, in the introductory chapter it will be given which model they are following. Okay, it will be written in the beginning of the book, the introductory chapter, it will be given whether they are following the open system interconnection model or the TCP/IP model. So that depends on the author of the book. So these are the layers. Now the functions of these layers also let us discuss. So as I said, the host to network layer performs the task of the physical and data link layers. So first, the basic characteristic is that the transmission medium features, okay, the propagation medium, that is defined by this host to network layer, the nature of the signals and the various the characteristics related to data transmission and data reception, okay, the data rate, the synchronization, all of that is handled by the host to network layer. This is for TCP/IP model. And it also handles the data transmission and reception between two devices or two nodes that are part of a network, or whether the devices are on two different networks. So the data exchange, that is handled by the host to network layer. Okay. Then the TCP/IP does not specify any particular protocol for physical and data link layers. So the normal proprietary protocols such as Ethernet, Wi-Fi, WiMAX, they are supported. Okay, I have also discussed about these things. I have discussed about them in the Internet of Things subject, also in computer networking and data communication, so you can check out those videos. So what is the data link layer protocols, all of that. So it supports all the basic proprietary data link layer protocols. Common which are used are Ethernet, Wi-Fi, WiMAX. Then is the internet layer. Okay, the internet layer in the TCP/IP model, the third level. So the internet layer, it handles the sending of data from a device which is in one network to another device which is from a different network. So source network to destination network. So the internet layer comes into play when the data exchange takes place between two devices, two nodes which are on separate networks, different networks, not in the same network. Okay, if they are in the same network, then physical and data link layer, they will handle that. They will be sufficient for that. But the internet layer comes into play when the devices are on different networks. So various tasks are performed by the internet layer, such as the routing of data packets, which is done according to a routing table. Then for this source and destination network, the devices which are on the source and destination network, the address, source and destination address is required. So addressing of devices is also done. So here this IP, that the purpose of this IP becomes clear. It follows the internetworking protocol, IP at the internet layer. Internetworking protocol is the protocol which is followed by the TCP/IP system, network architecture. That's why this IP is mentioned in the name of this network model at the internet layer, because it follows the internetworking protocol. So various protocols that are supported by this internetworking protocol is IPv4, IPv6, Internet Protocol version 4, Internet Protocol version 6, the internet layer protocols. That's why the name IP. Then comes the fifth layer in the TCP/IP system, which is the fourth layer, which is the transport layer. Okay, the fourth level, transport layer. So the transport layer, it follows the end-to-end message transfer capability. Okay, from one end, from the source end to the destination end. Okay, the source node to destination node. So it is done by the transport layer. Various things that are done by it, such as the data is transmitted in frames. We'll discuss about these things in detail in the upcoming videos. Now in just short way I will explain to you that data, when it is sent from one device to another, it is sent in the form of frames. Okay, and each frame has various blocks such as the source address, destination address, the data portion, header, all of these things are there. So the transport layer ensures that the data packets or the data frames are being received by the destination node or not, or whether there is any defect in the frames, there is any error in the frames. So all of these things are ensured by the transport layer. There is a very detailed analysis we can do on transport layer. There are a lot of concepts associated with it. So right now we cannot discuss it because it will be very confusing. So in short, you just understand that the transport layer, it ensures that the data which is being sent from the source side is being received by the receiver or not in its original form or not, whether there is any distortion or corruption of data. So all of these things are handled. So two commonly used protocols for transport layer are transmission control protocol and user datagram protocol. So in the TCP-IP model, this transmission control protocol is used for the transport layer, and hence the name TCP is used. So the TCP-IP protocol gets its name from the protocols that they use for the transport layer, that is the TCP, transmission control protocol, and the internet layer, internet working protocol, IP at the internet layer. So because of these two protocols, it gets its name, transmission control protocol TCP and internet working protocol IP, TCP IP model. Then we have as the application layer, the final layer, the fifth layer. So the application layer, it allows the user, okay, whether it is a person who is handling the device, or it is a computer, software, anything, to have an access to the network in which the device is. Okay, so it allows how, it defines various procedures on how the applications or programs that are running on the device or the computer, they interface with the lower level protocols. Okay, there are 5 layers, so the communication between these layers, okay, it is defined by the application layer. Now data is not merely transmitted between two devices, it is transmitted between the various programs or applications that are running on that device, that computer or any smartphone or whichever. So that is determined by the application layer protocols. So various services such as email, remote file access or remote file transfer, database management, information technology services, so they are handled by the application layer. And the commonly used protocols that are supported by the application layer in TCP/IP are Telnet, FTP, file transfer protocol, and SMTP. So these are the commonly used application layer protocols. So here we have completed the functions of each of the 5 layers. Okay, so this is the basic concept related to the transmission control protocol and internetworking protocol network model. I have already discussed the OSI model. So now the thing is that each of these layers, be it the OSI model or the TCP/IP model, each of these layers, it is very vast. You can write a book on each of these layers. So each of these layers, we will go into detailed analysis of each of these layers. So the next set of videos will be focusing on the physical layer. Okay, it will be from the point of view of both TCP/IP and OSI, because physical layer it has the same job, be it the TCP/IP or OSI. So in the next set of videos, we will be focusing on physical layer, then we will move to data link layer, then the other subsequent layers. So if we just focus on the physical layer alone, it will take a lot of time. So we will be covering a bit from physical layer, then a little bit from data link layer, internet layer, transport layer, application layer, then we will again come back to physical layer. So like that we can cover something from every bit of these layers. Okay, so we'll do this in cycles. So in the next set of videos we will be discussing about physical layer. So here we have discussed about the TCP/IP model. So I would like you to please watch the OSI model and other videos so that we can understand the subsequent videos in a better way. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.